Now we're going to get back together with our groups today. Last time you guys worked on that assignment and the group project, and I know you might need more time to finish. Some of our groups finished, but some didn't. We'll also use that time to work on our glitch to image assignment so that you can support each other with that. So what in the world is that? Well, a couple years ago, we had presentation assignments, and I asked people to tell me about new technology, and I had a student who was very interested in audio and video and things like that, and so his presentation was about glitching images, and it was really interesting to me. And this is just a Google search of glitch an image, and you'll find a lot of different things. And so what image glitching is taking an image and then applying some sort of effect to it to like scratch it, you know, sort of like a DJ only with art. So we're looking at how we might be able to, you know, scratch up this image and make it our own. So there's a bunch of different ideas, different things that you could do, different approaches. Here's some, like this one they say is a VHS glitch art, you know, like an old VHS tape. If you remember watching videos on VHS, because it was a tape media, it could get messed up. You know, there might be like an area of the tape that had gone clear or something like that, and you could see some weird things through it. So some people try to emulate that. So what they've done here, if you look at it, is they've just altered the colors on some of these pixels down here on this image. This one here is much more dramatic, you know, where they made it really fuzzy. You can really hardly tell what the original image was. This one's kind of cool. They just did some, you know, again, reverse effects on some of the pixels. It looks like the whitest pixels, or maybe a certain color of gray that they altered to be this aqua to give it this effect. If you look, you'll find all sorts of different ones. You know, just the TV vector sketch. I like these ones because I guess I've been in computers for too long. I've been stuck in front of many PC screens watching hard drive scans take place. So that's what this one is like an image of an old hard drive scan where it's showing you bad sectors on the drive that's kind of been overlaid on top of this other picture, so we could mix things up if we wanted to and just do all sorts of things. And for us, for Python, we wanted to look at files this week. So we're going to look at image files, but we won't actually be processing them in the same way that we process a text file. So we'll do an example of doing text file processing next week. But I wanted you to see how you could work with these different image files. Now, with this assignment, it's like a lot of other things that have to do with programming. If you take it and you say, oh, it says I have to apply 3 things. I'm going to do 1, 2, 3, I'm done. Then that's a great way to get the assignment done. You know, it'll be over. But it's not going to really give you any sort of experience in exploring and learning and thinking, ooh, how could I do this? The reason that I want you to think about those things are manyfold. Let me show you. Whenever we're looking at glitching an image, we're using the image as an object. And the object-oriented approach or object-oriented programming methodology is something that you're going to be getting more and more familiar with as you go through the different programming classes. So as we glitch an image, we want to think about some of the things we're doing here while we do that. First of all, our image is going to be a 2-dimensional array, right? It has rows and it has columns. Each of the different pixels that we see that shows us a color is really a point, an intersection on that 2-dimensional array. So this gives us a chance to practice some looping syntax and to visually see what happens with that looping syntax as we do things. Now, our colors are displayed as a combination of red, green, and blue. And different people have different levels of experience with that. So there's lots and lots of websites out there that'll help you. I like this one. It's htmlcolorcodes.com. I'll show it to you. It is going to go there. There it goes. So this htmlcolorcodes.com lets you pick a color. So I can say green, and then it shows me, I got to be careful of the ads over here to not click on stuff. It shows me the color that I picked, what the red, green, and blue value is for that color. So now I can use a digital approach to changing that color, because of course we can't just say this really like green to the system unless that has some sort of meaning. So the way we apply meaning for a color is the red, green, and blue color codes. So I can find any sort of website like this and find what the red, green, and blue codes are for whatever color it is that I'm looking for. So easy enough, we can find out what color codes we want if we want to try different colors in our image glitching. So go ahead and search for some if you want to. See if you can find any cool ones. Let's see what we can find. I know there's some really neat ones out there. There's a bunch of Marilyn Monroe, that is. Because you know the artists love to do Marilyn Monroe. And you'll find lots and lots of them for her. Some that are kind of weird, some that are just slid sideways. Like think about this one, how they're basically taking these pixels that belong here and it's shifting them over, changing their position in their row from these columns to these columns. So we could do that kind of change if we wanted to. We'd have to think about how to save what we had, and so we can get into much more complicated things or pretty easy things. So anybody find any good ones? There's lots of her. They did some mirroring, all sorts of things. Find any awesome ones? So how is this object-oriented programming? Well, I want you to think about how it is object-oriented programming, because if we can just sneak it up on you, where it's not really one of those things that you have to be slapped in the face about, then it can be really easy to understand. So when we're working with our image here, it's going to be an object. We want to display that object on the screen, right? So we're going to have to build a window to display it in. That window is going to be an object also. Those objects are going to work together to display that image on the screen. So when we're working with object-oriented programming, what we're doing is grouping things together, our code, into an object. So if I think about an image object or a window object, both of those have data or properties. The kind of data we have, an image object has pixels, right? The rows and the columns, and it has colors. So those are the data that belong to an image object. Our window object has like a width and a height, maybe some other things, a 3D approach, does it have a close button? Those things are data that we would see associated with a window object. Now, both of these objects also have behaviors or functions that they can perform. So for our image, one behavior it might let us update the color in a pixel so that we can change it. That would be a behavior or a function. Now, our window itself, we might be able to display it or close it. Those would be functions or behaviors associated with a window object. So object-oriented programming is simply grouping these data and behaviors together in our program code so that everything that has to do with an image, bless you, is grouped together, and everything that has to do with a window object is grouped together. So we're going to work with those a little bit. Now to get started, we can just go to the Runestone Academy. Let's do it. Any questions in the Runestone thing? I'm going to let you get logged in. We want to look at Chapter 8, more about iteration. In Chapter 8, more about iteration, we want to jump to 8.11, this two-dimensional iteration image processing section. And in this section, the first thing they talk about is the RGB color model and how our image is a two-dimensional array. So if you look at this picture here, this graph, this piece of graph paper, think about an image that's laid down upon it, where every pixel in the image is allocated to one of these cells, one of these intersections of a row and a column. Now, whenever we look at an array that's one-dimensional, we know that our index value is going to start at 0. And we're going to use that index value to point to a specific entry in our array. Well, when we're using a two-dimensional array like this, our index value needs to specify the row and the column. So instead of just one number, we would have 2. Now, in some programming languages, it's going to be expressed this way. In Python, we'll see it like this, where we have 2 different indexes specified in our code. And we're saying, this is the row, and this is the column within that row. Does that make sense? So our index value in our code gets a little bit more complicated because now we have to specify the row and the column. So if we look at this little pink dot here, it is in row R, column C. So that intersection point is what we're wanting to specify with our index value to get to that exact spot. So for the best way for us to do that is with nested for loops, right? We could have a for loop that went through each row, and then within that, we could have a nested for loop that processed each column within that row, right? We could go through and look at each pixel. Now, they talk a little bit about the RGB color model, the red, green, blue. Just saw there's lots of websites we can look at. Whenever we're looking at red, green, blue values, those values are always going to be between 0 and 255. Way back when we looked at binary, we noticed that 8 bits, the biggest number we can express in 8 bits is 255. So it becomes meaningful there when we see that as a limit. It's an 8-bit number that's being maintained for that color value. Now they give us some information here about some of the functions that are available within our pixel image. So our image object that we're going to use is going to be some code that's shared. We will be finding that code off GitHub so that we can use it. But in the meantime, let's look at what's here. Here's some. Let's run this. In this code, if we take a look at it, there isn't really an actual image file. they've just said they want to create an image and they want a pixel that has this color code 45, 76, and 200. Then they're going to print out the amount of red, which was 45, and then they set red to 66 and printed it again, and then they set the blue to whatever green is. So in this one, they were just messing with the color codes. Let's find one where they're actually looking at an image object. Here we go. If you scroll down a little further, where are we looking? I'm right above 8.11.3. Sorry, it kind of moves around a little bit. Now, in this small program, we have just a few lines of code. Here's the image that they're working with. This image file is luther.jpg. Okay, that's the name of the image file that we're working with. We're going to use that image file and make it an image object for us to work with in our program. The image object we create is going to be named IMG. After we make that image object, we're going to print its width, print its height, and then we're going to print out whatever the value is of the pixel at row 45, column 55. So let's see what we get there. So the width is 400 units. It could be pixels. It could be another measurement. Our height is 244. We've got our different pixel values here that we have been able to grab. And that's all we've got there. So it's not as helpful as it would be if we could actually see some things. So let's see if we can find the code to do this ourselves. Well, let's run this one. Scroll down a little further. Find Goldie Gopher. Now in this program, we're going to do a little more work. Let's read through the code before we run it. First of all, again, we're using this image library that we're importing. That image library is letting us make this image into an object. We're going to use Luther, again, which is the church bell thing. We're going to establish a window. And our window width and height are both going to be based on the width and height of the image. We're going to draw our window and turn off any sort of animation there. And then we're going to go into some for loops. And in our for loops, we're going to get each pixel, and then we're going to update each pixel's red, green, and blue value. And then with those new red, green, and blue color values, we're going to create a new pixel and overwrite the one that was there. So let's run this. So here's our image. So what is it doing with that, subtracting that red value from 255? Isn't that neat? So we're getting a really cool grayscale effect. So we took the maximum value of red, 255, and we subtracted whatever the current value of red was from it to come up with our new red value. Same thing for green and blue. So we end up with this nice kind of grayscale thing. So let's copy that program. I want to open PyCharm. And in PyCharm, before we copy the program, let's get prepared. I'd like to create a new folder for all of this stuff we're going to do with our images, because if we keep everything in the same folder, our lives will be much easier. Right now, looking at PyCharm, I have all of my Python code in this SP19 folder that I'm looking at. So I would like to create a new folder in that folder. So I'm going to right click and choose New Directory, because a directory is the old name for a folder, like really old, and I don't know why PyCharm would say it. but I want to name this directory image. So now that we've got a folder created, let's create a new Python file. New Python file. And I'm going to call this one glitch image. Now, you might want to create another one. This might just be your first version. So we'll just call it glitch image, and then you can update things however you like. All right, and now I'm ready finally to paste that code from Runestone. So I want to get this whole thing, copy, and I'm going to paste it in my new glitch image. Now, right away, it's complaining, right? Because I don't have this image thing to import. It says you don't have this module. So we need to go find that. Before we do that, let's make sure everybody's got it copied okay. So what we did, first we went to our main folder, and we right-clicked and said we want to create a directory. And we created a new folder or directory inside there called image. Now inside our image folder, we created glitch image.py, our Python code, and we copied and pasted that program from Runestone. Everybody got it okay? Lots to do there. Now we're going to go to GitHub to get the image program that we're going to be basing our code on. So let's see if we can find that link. I've got to find it. It's buried in here somewhere. Okay. 8.12. If you scroll down to that section within the Runestone Academy stuff, there's a lot more information that they'll talk to you about. If you read through that, we're going to kind of jump ahead and grab it ourselves. In 8.12, there's a link here where it says the GitHub page. It's in blue. We want to click on that. Now, GitHub is a cloud-based source code control facility, and that basically means that if you wanted to save all of your Python code off of the computers here, you could set up an account on GitHub and create a repository, a place to hold all your code. You could copy all of your code there. Then, when you were at home or on any other computer, you could just access GitHub and get to your code. So you'll be using it in some of the other classes a lot more. As you're getting started with Python, we don't throw that in at you too much. But we're wanting to find this cimage.py program. Now, with GitHub, right now, the only thing I could do is download this whole folder. We don't really need all these, so let's just open this cimage.py Python file. Now, I can't copy and paste it from here, but if I click this raw option, now I can select all. Control A, Control C to copy. And then in PyCharm, on my image folder, I'm going to create a new Python file again. And I want to name this one image and paste. Okay, kind of glitchy there, but as coders, it's important for us to be able to copy that code. So is everybody okay there? Need any help? Got it? Now I'm going to close this image.py file. I don't want to mess with it or accidentally change it or anything. I just wanted it in my folder. So now that it's in the same folder as my glitch image program, my glitch image program should be able to find it. I could try running it. Let's try. So it looks like it got past that import. It's mad about the Luther.jpg file because we don't have that. So that's okay.
Mine did not get the module.
Did it
I
not?
copy pasted everything, it did not.
Didn't like it. All right, so let's find an image. Because the problem that we have right now, if you look at your error messages, hopefully your error messages look like this. It is saying that it can't find this file, luther.jpg. So we want to really look at our error messages and kind of be aware of what's going on because we have a lot going on here. Some people are getting error messages about that import statement. If we're getting the error messages about that, we need to resolve them. But if we're getting these messages about not having that image, that's correct. We don't have that image file in our image folder. So let's go find an image. We don't need to use their ugly Luther image. Let's go find one. Now, one thing about this program is it has to be a GIF or a GIF, depending on how you like to say it. But that means it has to be. So don't get a JPEG, even though that's the example they show. They have software installed that we don't. So for ours to work, it will have to be a GIF. So find something you like that's a GIF. And on Google, we can do the special search that's always hiding from us. Let me search for something here. I know there's lots of group GIFs and I like them. So I'm going to search for group. And I'm going to put :GIF or GIF. And that should be one way that I am searching for only things of that file type. But I can also use the Google tools and change some of my search options to search just for that specific file type. But since Google has changed some of those since the last time I looked, I'll just do :GIF. Now I'm going to do Groot here, but I want to make sure it's really a GIF file that I'm looking at. And I want one that's not quite so dark. Most of these are like pretty dark. I would rather it be a little lighter for my changes to be noticeable. I'll just do this little one here. That works good. Now it could be copyrighted, so don't sell this. Just be using it for your own purposes. Okay, now that I found a baby Groot that I like, I'm going to save this. Right click, save image as, and I want to save this into my images folder. So that same folder where I'm putting those Python files. Oops, mine's on my H drive. Let me go find it. Now I'm going to name this something. I'm going to name it baby Groot.gif. Now if I go back to PyCharm and collapse and expand my image folder, I should see my image file there. So I'm going to change the name from luther.jpg to babygroot.gif. So whatever your file name is what you need to have there. I saved it into the same image folder. Yeah, so mine was in my H drive in my CIS120 folder. And if you need to just save it to your pictures folder and then drag it into your images folder when you're looking at PyCharm, you can. It doesn't matter. Just so you get it in there somehow. Now I'm going to try to run and see if everything's going to be nice to me. Something happened. Mine sort of flashed like it was going to run, and then it just sort of disappeared. If I look at my messages down here, I see this error. It says that this line 6, set delay, says image has no attribute set delay. So I'm going to comment that out and see if that's causing us some trouble. So it's doing something. It doesn't seem like it's doing anything. How about yours? Is it just sitting here too? Oh, there it went. I wasn't patient enough. So how come theirs was showing it as it was going and ours isn't? I would like for it to show it as it goes.
Set delay thing that's having an issue with.
Do ya?
Because where it says set delay 0 turns off the animation, I bet that means like how it did yours, where it loads the whole thing and then shows it.
Uh-huh. Well, actually, I think we can get it to do it, but I wonder. Well, first, let's just look at what we got, and then we can worry about that in a minute. So we've got our image here that we've selected. Mine seems small, but yet it does kind of take a little while. There is a bit of a delay. And in my image, I'm creating my image object named IMG. Then I'm creating the window to display it. We're creating the window to display it again based on the width and height of the actual image. So our window is the right size. Then we're using our image object and saying we want to draw it using this window. So we're going to get it set out there. And then again, we're thinking that this might be keeping us from seeing that update. I think that's a really good thought. We'll see if we can find anything out about that. Then, once our window displays, we're looking at our object. We go into a loop here. So here in our loop, we're saying for every row in our image, stop at that row. Now that we're sitting at that row, let's look at every column in that row. For each of those intersections, we're getting the pixel, we're updating that red, green, blue value, putting our new pixel out, and then doing this set pixel to actually update it in our image. And then we're drawing it. What if we moved that draw into our inner for loop? Let's try it. I'm going to copy it. Copy. And I'm going to paste it here right after this pixel is updated. Let's see if we can make that new image show up. Not seeing it. I've got some ways of doing it. They're just a little complicated, so I was hoping that would take care of it. It looks like it's not. I'm going to hang on, though, and let it run forever. Oh, it is doing it. Can you see it? Teeny, teeny, really slow. Do I?
Yeah, I've restarted Python and mine still doesn't recognize the image module.
It's not finding it.
I just
Do you see mine going? Can you see each pixel changing? And yours changing? Now yours, you already found it updated, so yours is going to wait and change all at once. is that? It's like, what is that, watching water boil thing? Did you mess up?
That's all it was.
Oh, okay. So what we did, we just added this image dot draw into RGB after we set the pixel. We just copied it. Yeah. If we're redrawing that every time a pixel changes, you're fine.
They're from the actual
It's in the pictures folder. What if I just create a new one?
So how could we make it to where it didn't show, redraw the screen until it was a whole new line? Would that make it run a little faster?
Probably.
How could we do that? Try that.
On this one.
changing the file in the picture. How can we make it where it only redraws after each line is working? Couldn't we change where we do that? Redraw? Think about your nested loops here. Right now, we're redrawing at the deepest level. Every time we change a pixel. So for every row, every column that we look at, we're redrawing that screen. It's taking us forever. Couldn't we move this out so that it was in our outer for loop and it only happens every line, every row? Will that speed us up? Still gonna be slow. But now we should see each line changed, so quite a bit faster actually, right? Because we're going through now, and instead of redrawing the screen at every pixel, we're redrawing it at every line. So think about those nested loops. So I like this one because we get a chance to actually see. That's why I was trying to get it to work to show us the output so that we can see what's going on there. So wow, what a huge difference we can make with where we put one line of code within our nested loops. Right? We can make a huge difference in performance. So coolness, I like that one. That's pretty neat. So what would you call this one? This isn't really grayscale. Is it like reverse video? That kind of what this one is, like a color reverse?
Yeah, I think it's different color from every pixel.
So that's what this effect is. So let's find some others. I'm gonna let it finish because I like it. All right, that's pretty cool. So I like this effect here. I wanna keep some information in my file. I'll set up some documentation down here at the bottom, and I'll say this is going to be my reverse color, I guess, reverse video. And I'm gonna copy this formula into my comments there. So now I know that that's how I would update my red, green, and blue settings if I wanted to reverse the colors on the red, green, blue scale. Okay, I'm gonna go back to the Runestone Academy because they have some additional formulas. If I can find it. Might have to open it back up again because I got too many things open. Come on, where's my groups? We could find some formulas in other places too, but I know they've got it right there for us. So this is like this one that we've got. That's the one we copied. We look at some other manipulations here. They say you can create a grayscale by averaging the red, green, and blue intensities and then using that value for all of them. Okay, so let's do that. I want a grayscale. And they say that's an average of RGB. So I'm going to create a variable and name it our average. And we'll say our average is going to be our blue plus our green plus our red. Now, because we're working with objects here, PyCharm is behaving a little different. You might notice that. I'm going to go really fast. Leave you behind, right? Because I hadn't shown you how to do that. Whenever we type the letter P with the dot, PyCharm recognizes that is our pixel object. That's what we said. Our pixel object is named P. So whenever we type the P, PyCharm automatically shows us all of the data that's associated with a pixel object, any kinds of data that we might want. It also shows us all of those behaviors, like, oh, you might want to get the blue value of the pixel. That's a behavior. You might want to get the green value. That's a behavior. So we have all of those. So that's what we're using. Now, the editor allows us to go really quickly through that by using these lists. So when I type the dot, the editor displays this list of valid actions that I can use for the pixel class. I can use the arrow key to move down and up to the different values, or I can start typing the letters, and then I can press tab to drop that into my code. So when I press tab on get red, it drops it into my code. And then I'm going to type the open and close parentheses. Now, some other things are available too, different keystrokes that'll help you be faster. Like I could go to get red and press enter. That would work also. So just different options for you to move quickly through your code. Okay, now I know what my average is. So I can set that to all of them, right? Do I even need to? Not really. I'll just get rid of these and say that they're all the average. Now I could keep those red, green, and blue variables if I wanted to. You know, if I decided that that was going to make things clearer for the next person that comes along, maybe I want all those separate variables, but I don't really need them, right? Because I'm going to be using this average for all of those pixel colors. Okay, so let's see if that works for our grayscale. My grayscale is kind of black with all of this green here. So hopefully something gray is going to show. Oh, that doesn't seem good.
You didn't divide your average.
Oh, did I have a fail in my average formula? Let's fix that. I've even got parentheses around it ready to go. See, I got sidetracked talking about how you could press tab and enter to go really fast and didn't finish the formula. So that is an example of how you can turn the image all to black. No, it is like, I don't know what you're doing. Oh, now it's super bad at me. Now we did have that happen. It's like an integer is required, not float. Ah, so how could I fix that? My average is coming back with a decimal place. How can I make it not have a decimal place?
You could do lower seal it or around.
One of those would work. Any of those. I could just do int.
I tried that. Oh, yeah, I've tried putting int on all three of them and it still comes back.
So put int on the answer around the whole formula. That looks grayer. That black was being a little dark gray. You're still going slow? That would make a big difference. Oh, Groot's finally turning grayscale instead of just black. Is her coffee grayscaling okay? Does it look cool?
Well, if you want to see, well, you did divide by 3 with it. It's not just so black. It's like,
Oh, wow, neat. I really want it. That's very cool.
Because you have so many lines to or all varying colors. You have some like there.
And my group doesn't have very many colors. I should have got something with more colors.
Yeah.
he's not a very good example because he doesn't have very many colors at all. We want something that's like colorful, but not too big, you know, and it's just hard to come up with the right thing. All right, so that's Grayscale. That worked really cool. The next thing that they tell us we could do is just a black-white. And then with our black-white formula, we would set a threshold and insert a white or a black pixel, things like that. Let's see if we can try a sepia. It takes me to a place talking about sepia, but it doesn't really give us any sort of idea about how to change it as far as our different pixels. So lots of different things we can try. So let's try doing multiple effects to the same image. What I'd like to do is in our image, I want to set my border kind of like a frame to be this grayscale. I don't want to grayscale the whole thing. So I'm going to start out with an if statement. So if, let's see what our for loops are running on, row and column. If my row is less than, I think I want to do my image. Yes, sir.
I've actually figured out a way to do that pretty easily.
Oh yeah, what's that?
Because it's so similar to Grayscale, I just added some red
Uh-huh.
we already had, and it pretty much did that effect.
Oh, cool. We'll do that in this one. Okay, so I think I want my top 10% of my image to be grayscale as a frame. So how would I do that formula-wise? You guys know I'm obviously not picking math this morning. I'm going to get the height of my image, and I want to know, do what? Divided by 10. That work? So if the current row we're on is less than the height of our image divided by 10, I'm going to do all of this stuff to make it grayscale. So I want to indent everything to make it under my if statement. Now we should just get a top border. So I'm going to run it. Oh, there we go. So that was good. Now it's going to stop after that. So I'd like to also have it on the side here, on the left. So I could say in my if statement, I'm going to go down a line and say, or column less than image dot get width divided by 10. I don't know how I ended up with that weird slash there, but it wants it. Is it like a continuation character? What is going on, Python? Okay, let me see if it likes that weird syntax. There we go. Cool. So as you watch your image, notice how this can train your brain as to what's going on with those for loops, because you can see what's happening. You can make them do what you want them to do and actually watch it and get an idea of what's going on so much better, to where your brain just totally understands what's happening. That's what we want. So how much red did you add to make it?
I did like 25.
So,
I only had like a very small amount of red just to see how it worked. I just basically in the red part of the where it says average, I just put plus 25 on it.
was red our first one? It was, wasn't it? Yeah. Okay, I want to try that. Yep, that looks cool. Again, if I had more picture stuff happening in my image, it would be better. Now we could do some other things too. Do it. Yours did some weird. You get some interesting things going on. Yeah, he's got some way effects. I'd like to try another one, another effect. I'm going to keep this if statement here, but before we go into the if statement, I want to generate a random number. Now, I have to import a random library. And then let's set a random column equal to, I'd like to just get a random number, rand int. And of course I want it to be less than 255. Well, let's see. If I'm doing a random number here, I think I want it actually to be less than my image get width, because I don't want it to be bigger than the row. Now I'm just going to add an if statement after our if statement that has to do with our border. And I'm going to say if our column equals our random column that we just calculated, then let's do a reverse video. So I want to set those, and then I want to update that pixel again. Now I'm going to go back to using our new red. New green and new blue. Now we could just make this random pixel white if we wanted, or black, or just gray or something if we wanted to. Just notice how we could randomly do some things. So let's try it. Now the way we have it set, first it's going to get a bad error. Missing run required positional argument B. Do I have to give it a begin? Let me try. There we go. I just updated the random integer call. Where did it go? So in our random integer, setting our random column, I set the begin to 0 instead of just saying an ending position. So we should just every once in a while see some random things. On mine, it just looks sort of like dirt. Like there's some little bitty dirt spots because of all the green and stuff in this image. So it's not really having a huge impact. Notice how that one little pixel is kind of actually small. We could do a range if we wanted, like a begin and end if you wanted to really be able to see it. So lots of different things you can try. All right, so your assignment is to explore with this. So hopefully you've got all of the image stuff working so that you can explore. Let me bring it up and we'll look at it, the assignment. You've got all of the information from the Runestone Academy site, so we've gone through that together because it is kind of hard to gather all that. You've got your folder all created with things. You're going to have an image file, and then you're going to do some glitching of it to turn in. Now I want at least 3 updates to your image, and see, what's it say? You can do like a negative thing and then 2 additional things like we were doing grayscaling the framing, some random pixel changes if you want, however you want to do that. Now to turn it in though, you're going to need to give me the whole folder. So how can we do that? Well, I want to check in PyCharm. And in PyCharm, I should be able to right click on my image folder. And there it is. It's down there way in the middle. It might be, it's kind of hard for me to find. It might be hard for you to find. There's this option that says Show in Explorer. And that'll open our folder for us in File Explorer. So now I'm looking at my image folder here in File Explorer. I want to create a zip file of it to submit. So I'm going to right click on it to send to compressed zipped folder. When you do that, it'll pop up with the same original name of your folder with the .zip extension. You can just press enter and it'll save that compressed zip file. Now that zip file is going to have all of those things in that folder for me. You just submit that whole zip file. So there should be instructions on the assignment as to how to do that. But it is pretty easy. As long as you can find your folder, you can get it all zipped up and turned in. And I really like seeing what you guys come up with. So come up with some cool things. Now it's 10 after. As I mentioned, we have the different groups set up to work. I don't know who we've got here today. Vanessa and Chad are here, so they're ready to go. Madison and Haley and Aaron are all here. Adam and Jonathan and Aaron are all here. Oh, we're in pretty good shape. Okay, we get 2 of our other guys. Looks pretty good. I think most of our groups are here. Jonathan and Boone, I'll let you guys get together and you're going to look at the assignment for week 14 that they did last time. That was a group assignment. And then everybody else is going to be working on their glitching an image. I'd like for you guys to make sure you've got the group assignment done first and then start working on your image glitch. I know it's kind of a solitary thing, glitching your image, but if you work together, you guys might have some good ideas that you want to share. So don't expect you to have that one done today. It's not due until Tuesday. So play with it. Like I said, try to get it to where those loops are just so visual that you can see what's going on as you go through those rows and columns of those images. Any questions? All right, let's get into your groups.
Can I see your code again real quick?
Sure.
I tried adding the random column thing and it's saying that it doesn't have a get with attribute.
Do you make it go crazy? I'll just leave that up. It can get nasty fast when you're working with those objects.
We had time on Tuesday to work on that glitch.
I think that we will have a little bit, we'll definitely have lab time, but try to get to where you feel like you're pretty close with it. Okay. Ah, Nick, I have never looked at that thing. Darn. I'm going to do that right now.
Is group 5 here?